Hello there. A little bit early, but I think that's okay. Hopefully, some people will be joining soon. Curious, just while we're waiting for others to join, if anybody wants to introduce themselves. I'm curious who here was here last time. Looks like there's 3 viewers live, 5 now. Great. Who was here last week for the first of my live streams? Just mention on chat if you're comfortable doing so. I see already. Even before that, there are some questions on the chat, so that's cool. The first question is, I guess I'll just answer that. I have a small question for you. Request you to answer the question before you start coding session today. I think the question is, will Golang still be in demand in the era of AI? And does it have any use cases on public blockchain? So 2 questions there. I don't think there's any reason to think that Golang would be different than any other language as far as it goes with regard to AI. And I'm not concerned about AI taking away programming jobs. The hard part of programming is not writing code. It is understanding customer problems and making code do those things. And AI is nowhere near doing any of that yet. So I'm not concerned about AI taking away jobs. Having said that, I do think there is room for using AI to do our jobs better. And I hear it's hard for me to be. Sorry, I'm not speaking well. I'm apparently quiet. Let me see if I can improve the volume. Thank you for letting me know. That would have been bad to get farther in without being able to hear. Okay, I've tried to boost the volume. Let me know if that sounds better. If not, I'll try something else. So back to the question about AI. I don't think we need to really worry about that. However, I do believe there is room for using AI to improve our jobs. I use ChatGPT sometimes when I have. I was using just today, in fact, for some JavaScript related stuff, asking which versions of JavaScript supported new features and so on. So there's definitely a place to use AI, but I don't think we're in any danger of it taking our jobs away. On the second question, are there any use cases in public blockchain? There's a ton. A large percentage of Go jobs I see out there are blockchain related. I ignore those. I am not the least bit interested personally in working in blockchain. I'm not a fan of cryptocurrency. I think there are legitimate use cases for blockchain, but it's not an area of my interest. So I have kind of intentionally ignored that area of Go, but it is very popular among blockchain projects. So there's definitely a lot of Go in the blockchain. So if that is your area of interest and you're considering whether or not Go is a good match, it's definitely a good match. So let's see what we should do today. I had 2 ideas in mind. One is that I could pick up from where we started last week and continue delinting the Gopher.js project. I have a couple updates I could offer throughout since then. A week ago, I've merged some of the stuff and talked to my co-maintainer. I could work on that, or if we think that might be monotonous or boring, we could do something else that I have never done before. I had the idea of making my own linter. So if you'd be interested in live coding while I build my own linter, I could do that. I'd love to hear what you think in the chat. If anybody has a preference for one or the other, we don't have a large group here, so if anybody has an opinion, that might be the winning vote. What would you like to do today? Do you want to watch me continue to delint the Gopher.js project, or would you like to watch me try to build a linter and learn how that works from scratch? Either way, let me. I should have done this already. Give me just a moment to get my screen ready to share. I want to, of course, show you my screen, not just my face while I'm coding. That wouldn't make for a very interesting coding session. So, all right, I have 3 votes for building a linter. I think that's the winner. And the question, is it going to be compatible with Golang CI linter? Yes, that is my intention. So let me pull up the website for Golang CI lint, and we'll get started. So I started to browse this earlier today, but I didn't go far because I wanted to keep it fresh for the live stream. But they have a nice section here in the documentation called new linters. And then they tell how to write a linter. So I'm going to follow this tutorial they reference. And we're going to build a linter. I'm not sure how easy or difficult this is going to be because I've never done it before. So I just briefly scanned the first couple pages of this without really reading it. So let's read it. I'll probably read it out loud. We'll dive through it. It says it's a 27-minute read. It could be a bit long. We'll see. We'll see how far we can get today. Comment, it would be great to get insights into how you get started with something like a new linter. I agree. I would love to know how to get started with a new linter because I've never done it before. So we're all learning together today. All right, so the article says, we're going to write a useful linter for Go using the go/analysis package. Then we will integrate it into GoVet and Golang CI lint. We might skip the GoVet part. I'm not exactly sure what that entails, but we'll see. I'm less interested in that. I'm more interested in the Golang CI lint. What to lint? Let's find all printf-like functions that don't end in F. It's the Go convention to name such functions with F at the end. I don't really care about that linter, but that seems like a reasonable first project. So we'll just follow the tutorial, and then once we have the tutorial working, we can put in our own logic and lint something that we actually care about. Writing a simple linter. Sample program with an issue. Let's use the following example program for the explanation and testing. Here, my log should be my log F. Okay, so the function is called my log. Maybe I'll zoom in a little bit. I think I don't like the formatting on this page. I can make the text bigger, but it doesn't use more of the screen. I don't know if people can read that. I hope so. It's not an optimally designed website for this use case. But hopefully the code we can see. Maybe I'll copy that code into my editor so we can look at it more clearly. I'll make a sample directory for this project. I'll just call it my linter. And I'm sure we'll delete this code because it's just sample, but to start with so we can see what we're doing. Let me do this. So there's the code. Let me zoom in here. I can do that a little more easily than I can on the browser page. Okay, so here's the code we're looking at. Someone asked what site this is. So I'm not actually sure. It's I went to Golang lint. Pardon me. I went to Golang CI-lint.run, and then the left-hand column I clicked on new linters, and then I clicked on this tutorial. So that's how I got there. The actual site itself is disaev.me, and there's the whole URL. I'll put that URL in the chat if anybody wants to just jump straight there. All right. So let's look at the code here. So it's pretty simple code. It looks like just a function called mylog, but we want the linter to complain and call it mylog f. Why is package main complaining? Do I have other? Oh, I probably don't have a go.mod, so it's complaining about that. I'm not worried about that right now. So that's the code. That's the code that should fail the linter, and it should tell us we need to put an F at the end of this. So that's what we're aiming for with this tutorial. What is AST? Usually such issues in code are detected by analyzing AST, or the abstract syntax tree. Let's visualize the AST of our program. By this online visualizer, it's marked out. What does that indicate? Is it no longer available? I'm not sure what that means. copy that code into that tool and see what it does for us. Parse, is that what I want? Okay, so it, yeah, builds an AST for us. That looks like a really handy tool to keep in mind when we're doing linting. So let's keep reading. The most interesting part, let's visualize the AST. Yeah, okay, sorry, that's where I was. And then, oh, if we click on that, it shows the same information we had over there. Okay, that's nice. The most interesting part of the AST for us is the mylog function declaration. We simplify it to, so here we have an ast.funcDecl function declaration. The name of the function is mylog, and it's some sort of ast.ident struct that has that information in it. I don't know how much detail I should go into this AST. If anybody is really confused by what we're looking at, just let me know, and I'll try to go into more detail. As you know, this is my first time doing a linter, so I don't have a lot of information myself, but I do have a little bit of sense of this AST stuff. Anybody who watched last week saw some of this already because we were dealing with the AST when delinting some of the Gopher.js stuff. So it's the same package. The AST package is the same that we were playing with last week a little bit, and that we're looking at here. But basically, this is a in-memory representation of the source code as parsed by Go. So this Go package, I'm not actually sure which package it is. It's called AST. I don't know if it's Go/AST. We'll get there, I'm sure. But this package is part of the standard library, and it is used when you compile Go programs. One of the first things it does, of course, is read your source code off of the disk and parse it into an AST. Unless there's syntax errors, then it stops. But assuming you have valid code, it reads it from disk into an AST like this. So this is part of the standard Go library. And that's one reason why there's so many linters for Go, is because there's just nice tools that make it really easy to do that, which we're hopefully learning about today. Let's continue. To analyze AST, we need to prepare it first, okay? So I think this is the beginning of our actual linter. So that file I created here, I should probably put this, I'm going to put this in a subdirectory so we have it handy for testing, but it's not in the way for writing our linter. So first things first, let's initialize our module. Go mod init. I like to use GitLab. I have a GitHub account too, obviously, but I'll use GitLab for this. I'll use my username, and then I'll call it my linter. And I'll try to put this code online, so if anybody wants to play with it at that URL, you can. Of course, I'll put that in the notes on this recording as well. All right. Oh, it doesn't. Oh, reminds me I just need to run go mod tidy. Okay, I can do that. Tidy. Now I have my main.go. I'm going to move that into a directory. I'll just call it example, I guess, for now. Now I should probably commit this somewhere. So I guess I'll make a project on GitLab. It should just take a moment, and then we can commit this and start pushing it up. So let me do that. Actually, I probably used the wrong path because I have a boldly go path where I should have put this. So I'll find out here in a second. GitLab interface has changed recently. Things have moved around. Blank project. I want to put this in boldly go, and we're going to call it my linter. I wonder if I should use a better name for that. Whatever. Maybe I'll rename it later. I should give it a better name because I want this URL to live for a while. Anybody who rewatches this video should be able to come back to this URL. And my linter isn't very descriptive, so let's just call it linter tutorial. And I don't want a README, and it should be public, so all you folks can look at it. So there I have created the project. Now I'm going to reinitialize this go mod since I changed my mind about the name. So just remove that file and start again. Go linter tutorial. Tidy. Add those files. Oh, I can't add them obviously because I haven't initialized the Git repository yet. So I'll do that next. Git init. Git add remote. So if you create a brand new Git repository from scratch, you're not cloning one that's already existing, this is how you do it, if anybody's wondering or hasn't done that before. Remote add, I think. No. Remote add. Oh, I have to go to name, of course. Git remote add origin, and then there we go. All right, now I can commit those files, I think. Yeah, git add go.mod example. Just call it initial commit. Just push that up to GitLab just to see that it's there. Now if I refresh, we should see some code. Great. So now that it's live, and as I make progress today, I'll continue pushing it up there, and it should remain live. Okay, so where were we on this tutorial? We need to analyze the AST. We need to parse it first. So I think we need to copy this code into our main package. So let's do that. I wish there was a little copy button there, but whatever. So we're going to create a file called main.go. And we're going to put this inside. Just pasted it. Let's save it. We have some sort of warning here. Oh, yeah, it thinks my log is unused, of course, because it's unused. I'm not using it yet. I don't care about that, though. All right, what's next in the tutorial? We did our copy paste. Stack Overflow would be proud. Parser.parse file parses source file and builds the AST. AST.walk visits nodes of the AST with our visitor. It continues visiting nodes until the visit method returns nil or all nodes are visited. In the simple implementation, we parse source files and visit all AST nodes. Okay, let's look at the code and see if all that makes sense. So parse file parses a source file and builds AST. Okay, so it just takes the file names, it takes as arguments Go file names, and it ranges over those. And as it get for each one, it passes the file path into parse file, which is part of the Go parser package. So that's not something we wrote, that's part of the standard library. And then if there's an error, it does a log fatal. And then, so assuming it succeeds, then F contains our AST. So then we walk our AST, the abstract syntax tree, and we use this visitor struct. Presumably it needs to match an interface. Yeah, it needs to match this visitor interface, which just takes a single, it's an interface with a single method of visit. That takes one argument and one return value. And so we can see that's implemented here. So this visit receives one node at a time. You've probably seen code like this before. If you've ever, well, I can think of two areas where people usually see this sort of code. One is if you're walking, say, HTML. If you use the standard library's HTML parsing logic, you do this sort of thing to navigate through an HTML structure. And that is an AST of sorts. HTML uses ASTs as well. So that's why it makes sense that it's a similar thing. Another place where you might see something similar, although it's not an AST, is if you're trying to recurse a file system. So if you want to recursively list all files in a directory, then you would do something like this. And you could use most operating systems, or I'm sorry, most languages, Go included, has the ability to walk a file system. So it just kind of passes file names into a function similar to this and lets you do things with it, whether it's just printing them out or deleting files or archiving them or whatever. So you may be familiar with this sort of approach to programming. So you have this function that gets one thing at a time, and something else is responsible to pass all the things one at a time into that function. That's what we have here. So if node is nil, we return nil. Otherwise, it looks like we're just printing stuff out. But we should run this and see what happens. Oh, yeah, that won't work. So I need to let's do go build main. Go build like this. Yeah, seems to work. It just prints out a whole bunch of stuff. It prints the file itself first. Is that expected? Not sure why it does that. I guess that is what it's doing. So it prints the node first, and then it prints. And I guess the first node is the whole file. Maybe is what that means. And then for each sort of symbol or section, yeah, I can see it. So here for the func, it's like the whole function is one node, and then it prints the details about that. So that I see what it's doing, and it makes sense. I hope others are following along. If you have questions, of course, just let me know. All right, back to the tutorial. What's next? So yeah, we already jumped ahead and did this part that it's telling us to do next, where we ran it with the example.go. You can see that it visits and prints all nodes. Now let's write linting in visitor.visit. Okay, so we can put some sort of linting logic in there. So I guess I can just copy this. I hate copying and pasting code that I don't understand, but I don't understand it yet, and we'll come to understand it over time. So we'll just do it anyway. So let me save that to resolve imports. Okay, good. Actually, you know what? Before I do that, let me undo that. Completely undo that. Okay, I want to commit this. Did I already do that? I guess I did. No, I did not. You know what else I'm going to do? I'm going to add a README. That has a link to this tutorial for future readers. Whoops, wrong button. There we go. I'll make the README a little more explicit later, but for now, that's a good start. There we go. Got a nice little README there with a link to the tutorial. I'm going to close this tab. I don't really think I care about that the rest of the video today. All right, so I was going to make this change. Let me do that again. So I wanted it in a separate commit. That's why I did what I just did, just to have a nicer history. And also I can look at the diff that way and see what it actually changed. All right, okay. Let's paste that. Yeah. So we can see that when I do diff, bytes is removed for some reason, go printer is removed, and strings is added. And then here's the actual changes. So we're checking to see if it's a function declaration. And if it's not, then we just return the visitor as it is, this. That's a little bit strange to me. I'm really curious why we're returning a visitor here. I'm sure there's a completely logical reason. It's just a little bit strange. Like usually when I have these walking sorts of approaches, you're either returning a Boolean or the next node in the list or something like that. But here we're returning V. So I don't know why, but that's interesting. But what matters for now is that we're only interested in function declarations. So that means that constants and variables and packages and anything else, we're just returning without making any changes. So, hey, thanks for the comment. Says keep up the good work. Glad you're here. All right. What's next? So then we look for the parameter list from the function declaration. So we call, I'm assuming these are all nested structures or structs. So func decl.type.params.list. And if the length of the parameters is not 2, then we return. So because we're looking for printf-like functions, so that means that it takes a format string and a list of arguments. So that's what this comment here is explaining. So the first argument should be a format of type format string, which I assuming we're going to check the string type in a moment. But first it should be 2 arguments. The first one is the format string. The second one is the variadic argument of ... interface, or ... any if you're using Go 118 or later. So that's why it's looking for specifically 2 arguments. If you have 3 or 0 or whatever, then it's not it's not relevant to our linter. Let's keep going. Okay, now we're checking the type, as I expected we might. So we check the first param type. So it's doing a type assertion here that it's of type star ast.ident, or pointer to ast.ident. I don't know when this would ever fail. Yeah, I don't know how you would, maybe it can, but I don't know how the first argument to a function could not have an identity, not be of this type. I don't know how that's ever possible, but whatever. I guess it's defensive programming. And then we check if the type's name is of string. So, good. If it's not a string, if it's an integer or a struct or a context, whatever, then we just return, or early return, and we're not going to trigger the linter failure. Then we do something similar with the second parameter. So this answers my question. The first one could at least be a variadic. Well, I'm lying when I say that, but I said that I didn't know what other type it could be other than an ast.ident. Well, here's one example. It could be an ast.ellipsis. However, that would never be possible on the first parameter of a function with more than one parameter, because this is only ever valid as the last parameter. So I still don't know what else this might be, but I did learn just now that you can have at least ast.ident and ast.ellipsis as parameters. So that's interesting. So this does the same as before. If it's not a .ellipse, then, or if it's not an ast.ellipsis type, then it cannot be the variadic arguments that we're looking for. So we can return early. And then next we check to see if the type of those, I don't know what ELT stands for. Why don't I find out? Come over here, and with the magic of my IDE, I will find out what ELT is. Ellipsis element type. There we go. That's what it is. So if the second parameter's ellipsis element type is not an interface, then we early return. So by now we've confirmed that it is a variadic argument and that it's an interface, but we haven't yet confirmed that it's the empty interface. So that's what we check next. If element type dot methods is not nil and the length is not equal to 0, then it's not the empty interface. I don't know when methods would be not nil. Details I don't understand about this yet. This part makes perfect sense. If there's more than one argument, or more than one method in the interface, then it's not an empty interface. So now we are through the thing here, and we check to see if the function declaration's name.name, that's cool, ends with f. And if it does, then there's no problem. If it doesn't, then we print out an error. Print like formatting function %s should be named %sf. Okay. So we made it through the changes that we just made. Let's see what the tutorial says next. I'm guessing we're going to run it. Run it and ensure that it works. All right, let's do that. Go build main.go. Actually, I'm going to go build dot. That's safer. And then let's do linter tutorial with the input. There we go. We built a linter. That was easier than I thought. Printf like formatting function mylog should be named mylogf. Now, we still haven't built one that's compatible with Golang CI lint, but we built a linter, so we're partway there. I think that's the next section here. We implemented blah, 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 blah. We have implemented a simple linter without Go analysis or any other frameworks. Let's move on to how we can use Go analysis to improve it. Yes. Go analysis is an API for modular analysis. Also, it's a common interface for all linters. This API simplifies developing a new linter. Well, not all linters. Not mine, not yet. Soon will be. This API simplifies developing a new linter. It forces using best practices for static analysis, for example, working with one package at a time. Okay. The primary type in the API is analysis.analyzer. Pardon me. The primary type in the API is analysis.analyzer. An analyzer statically describes an analysis function, its name, documentation, flags, relationship to other analyzers, and of course, its logic, of course. To define an analysis, a user declares a variable of type pointer to analysis.analyzer. Okay? So I guess that's just the definition of the type. Let's pull this up in the Go doc. What was it called again? Was it Go/analysis? Yes. If you're not familiar, this is the best tool in the world. You can look up the documentation for any Go package, as long as it's public, whether it's in the standard library or not. I guess it's not the standard library. It's apparently Xtools, but that's kind of unofficial experimental standard library is what that means. But that's cool. And we're looking for type analyzer. So yeah. So there's the type. Let me zoom in a little bit. Oops, not out. Make it bigger, easier to read on the screen. So I think that's the same that we just saw. Indentation's funky, but otherwise it's the same. All right. The most interesting field is run. It's where linting logic lives. Okay. Don't understand that yet, but I'm sure it's true. It takes an analysis.pass as an argument. And there's that definition. A pass describes a single unit of work, the application of a particular analyzer to a particular package of Go code. The pass provides information to the analyzer's run function about the package being analyzed. A lot of this feels like it won't make sense until it makes sense, if you know what I mean. Like each sentence alone might make sense, but I'm not quite putting it all together yet. A pass describes a single unit of work. Okay. The application of a particular analyzer to a particular package of Go code. So you might have 25 analyzers, I'm guessing, since like Golang CI lint has all these different linters. I'm guessing each one of those counts as an analyzer. And then a pass is like a mapping between a Go package and one of those. So if you have, let's say your project has 5 packages and you're running 5 linters, then you have 25 passes, is how I understand this so far. The pass provides information to the analyzer's run function about the package being analyzed. It provides operation to the run function for reporting diagnostic and information back to the driver. Okay. The fset, files, pkg, and types info fields provide source positions, the syntax trees, type information for a single package of Go code. We don't need type information, so pkg and types info aren't needed. Wait. But do we need to know that the first argument of printf-like statement has type string? Yes, we need. But AST contains enough information about that, therefore we don't need type checking. Okay. So I guess for this particular exercise, we can ignore pkg and types info, but they're available if you need them, if you're doing a more advanced linter. Why do we need Go analysis? There are two main reasons to use Go analysis: unified interface and code reuse. Sounds like a useful thing to do. Two useful things to do. Go analysis provides a unified interface for linters. It simplifies their integration into IDE, meta linters, like Golang CLint, I suppose, code review tools, etc. For example, any Go analysis linter can be effectively run by Go vet. We will talk about integration later in this article. Okay, I'm probably not interested in that, but we'll read it as I mentioned earlier. In our sample linter, we require a user to pass a list of all files to analyze. But the convenient way is to run linter without arguments or with .. to run it recursively on all the files in all packages. We can implement it ourselves. I already did in the first version of Golang CLint. Requires 100 to 500 lines of code. Or we can use Go Analysis API to do this in 10 lines of code. I don't know. Do you think we should do the 10-line version or the 500-line version? Which would be make for more interesting watching? Well, I'm going to do the 10-line version now. If anybody really wants the 500-line version, maybe we'll consider that for a future video. All right, let's use Go Analysis. Yes, let's. Let's port our simple linter to use Go Analysis API. I've made the repository. This is funny that all these, not all, but many of these links have the strike through. I think that's a CSS mistake, but maybe it's intentional. I've made the repository Go printf func name for that. Okay. Do I care about this right now? So I think this is basically the same linter that we're building. But I don't want to just look at his repo. I want to do it myself, right? First, let's define the project structure for the following popular Go project layout. This is what I think it is. I'm about to scream. Yeah. By the way, if anybody's watching this, this is just a side rant. This Golang standard / project layout, there's nothing standard about this, and there's a lot of bad ideas in here, honestly. The most important thing from the README is the second sentence. It is not an official standard. Remember that. It's not an official standard. The project name lies. If you want to hear my full rant about that, maybe I'll make a video about that later, but don't trust this repo. All right, so what are we doing? First, let's define the project structure by, or whatever. I'm not going to do that because the PKG, I'm not going to do that. That's one of the worst pieces of advice in that repo is this PKG thing. That's outdated. The official Go project used something like that for a while, and they realized it was dumb, and they've moved on. So I'm not going to do that. Otherwise, I'll probably follow this. I'll just put it in something called Analyzer. So let's create something. Yeah. So we're going to do something similar, but not exactly as the tutorial says. So I'll make a CMD folder, and I'm going to give it a name that matches my repo name, since that's what we're doing here. The linter tutorial. So I'm changing names to be consistent with my own thing, but it's the same concept. And then we're going to put this code into a main package there. So effectively, that main I already created is going to be obsolete, I guess. I'll probably delete that when I get there. All right, so these imports are not working because I haven't added them yet, but I want to change this. This is not the import path I want. I want to use, this is supposed to reference the current project I'm building, right? So I'm going to use my own name here, gitlab.com/boldlygo/ what did I call it? Linter tutorial / analyzer. Now that package doesn't actually exist yet, but that's what I'm going to call it. And this other one just needs to be imported, which I'll worry about in just a second. I'm going to create this analyzer file first. So let's copy and paste this DLDO. All right, now this one fails, but if I do go mod tidy, it should fetch the things I need. Or I could do go get in the package name. This is just a shortcut because I don't have to remember the package name that way. Now you'll see it's working, and this one is also working. So I've created that package myself. That's this file here, and then I imported both this one and this one by running go mod tidy. You know what I think I forgot to do though before I mess with that? I want to commit the changes I already made to main.go, the original one, right? Yeah. So all this stuff that we just walked through, I want to commit that. So I'm going to do that now. All right. So that's the previous step. I should have done that earlier. So now I want to add CMD and analyzer. All right. So the two packages that are referenced here are both in the X tools module. See that? So the one is a go analysis. That's the one we've been just looking at. And this other one, don't know what it is yet, but I'm sure we'll find out. It's under go analysis single checker. So those are both imported with this. And then we have two indirect dependencies. All right. So we've done that, but I don't know what has happened yet. It says notice what's changed. I think I'm going to go just like I did with the others. I'm going to let's just walk through this code and see what it does, make sense of it. So main is pretty straightforward. It has a single function called main, of course, which calls the single checker main. I guess it's a good time as any to learn what that single checker thing does. Package single checker defines the main function for an analysis driver with only a single analysis. Okay, so simple enough. So that's if you're running this in Golang CLint, for example, you wouldn't use this because you have multiple analyses. But since this is a simple test, it's just like a simple bootstrap for a single analysis. That's nice. And then we call analyzer, which is this thing we just copied and pasted with the other file. Let's see if we can make sense of that. So here we name the linter, I guess, or the analyzer to be more technically correct. And it's called go printf func name. I'll leave it alone. I don't care. And it's something to describe what it does. Checks that printf-like functions are named with f at the end. All right. And then we have a function called run. And then we define that the run function is this run function. So this is the actual logic that's happening. It takes a analysis.pass as we read in the tutorial documentation and returns an empty interface and an error. So this is we're assigning to this variable called inspect a function. That function takes a node and returns Boolean. All right. So this is similar to what we had before, right? Yeah, in fact, it's very similar to what we had before. So if our node is not a func decal, then we return true. We early return. But previously, in the other version over here, we were returning v. So this whatever that single checker does gives us an interface that's a little bit more intuitive to me. So we can apparently return a Boolean. True to probably means keep traversing the tree, and false would mean stop traversing the tree. I'm expecting. I'll check in a moment, but I expect that's what that means. So that's a little more intuitive to me than this earlier version where we're returning the AST.visitor. So, but it looks like it just does a simple conversion along with probably other things in the background that make this a little more intuitive. But logically, it's doing the same thing. So here you recall we're calling func decal, and if it was not okay, we returned early. Exactly the same here, except now it's returning a Boolean instead of that visitor type. Then we do the other checks as well. Do we have 2 arguments? If not, if it's not 2, then we return early. Is the first one an AST ident? If not, return early. Is the first one a string? If not, return early, and so on and so forth. So it's exactly the same as before, just modified to return a different type. And then now this is the interesting part. So if you recall before, when we had a failure, we just did an fmt.printf. We just spit it out to standard output. Now we call pass.reportf. We give it the node position, which is probably, I'm guessing this has to do with a line number and file, probably a file name, line number, and maybe the position on the line is probably all that information. And then it tells us printf-like formatting function %s should be named %s f. So it's the same verbiage essentially, but it's done in a different way. So it's, rather than printing it directly, it's passed up the call chain. It's passed back to the single checker. And then here, okay, so now, so that's inspect, but we've received this pass argument, and we use that pass argument to go over all the files. So remember, a pass represents a package, so it could have anywhere from 1 to n number of files in that package. And so here we run over each of those files, and we call ast.inspect on that. So that's pretty straightforward. Now, one thing that I think is funny, and maybe there's a reason for this, but I don't know why this is an inline function. I feel like this could be an external function. And maybe I'll try tweaking that in a moment, because it's done as a closure here, but it's not referencing pass, so it's not closing over any actual. Oh, it is. It's closing over it right here. Okay, so yeah, that actually does make sense. So disregard that, and then we return nil. So I don't know what that means. I don't know what, if we wanted to return something, what it would be. I don't know why that's nil. Maybe if you're modifying it in some way. I don't know if you can modify the source code as you're doing this, but this linter isn't doing that. So I guess we're okay. So we've made it through that. Let's go back to this tutorial and see what's next. Notice what changed. We used ast.inspect instead of ast.walk. Yep, it requires less code. To do that, we just need to remove the visitor and return true instead of the visitor. Yeah, I noticed that, and I actually like that a lot better. We iterate over pass.files to get syntax trees, ASTs for the current package. We don't load them manually. So I guess that's a detail I didn't call out. It wasn't obvious, but these files aren't like disk files or whatever. These are the ASTs for the files, apparently. Yeah, it's a slice of pointer to ast.file. So that makes sense. Pardon me. So the question is, if I wasn't calling pass again, we could extract the function. Yeah, I think so. So if we weren't referencing pass, then we could extract it to a separate function. And honestly, I still might in a different way, but maybe I'll talk about that if we get there. Pardon me. So yeah, if we were not referencing pass here, then this could just be a standalone function of its own. And then finally, we report about found issues with pass.report instead of fmt.print, as I pointed out. So great. Let's run this and see what happens. Go build.cmd. There we go. So we have the failure, and it. I was guessing that it would include the file name. You remember I was guessing that this node.pos included a file name, a line number, and possibly a line, like a column or a position on the line. It looks like it has all of those. So it's line 5 and position 1. Is that accurate? Here it is. Yeah. Nope, that's the wrong file. Example main line 5, yes, and position 1. So the function declaration starts on the first character. So yeah, that makes sense. So And this is the information that your IDE, like VS Code or Golang or whatever, will use to put the squigglies under the right part of your code. It can read this data to know that. All right, what's next? So here they ran it without an argument. So let's try that. And we get a nice little help output. And then this help output comes from the single check function, right? Yeah, single checker.main. I guess it reads command line arguments and everything for us. And if they're not present, then it gives us this nice little output. So that's cool. Thanks to Go Analysis, I get a lot of command line options. Now it's time to test it again with example source code, which we've already done. And we get the same output, the only difference being the different file paths since we're using different file names. Yes, it works. Great. AST.inspect versus inspector. All right. Did you notice an ineffectiveness in AST.inspect and AST.walk? We visit every AST node, binary expressions, variables, constants, etc. But we need only function declarations. Can we visit only them to improve performance? Yes, we can. Go analysis contains inspect.analyzer. This analyzer filters AST nodes by types. First, we should require it as a dependency of our analyzer. Okay. So that's the type declaration there. Change, but first we should require it as a dependency. Okay, I'm happy to do that, but it doesn't tell me how. Change the run function too. Okay, let me commit my current changes. Or did I do that already? Yes, I did. All right, perfect. So let's just copy this. We'll look at the diff and see what happens. Analyze. We're replacing run with the new run version. Let's see what the difference is. All right, it fortunately was able to detect the correct inspect. Actually, I don't think that is the correct one. I don't think this AWS Go service director thing is the right one. I think it's, I don't think that's right at all. Let's see if we can find the right one. So I have a suspicion that it's going to be right next to this one. No, maybe not. Maybe one level up. I don't know. Directories. No, I don't know where it is. Okay, so what I'm going to do is I'm going to, because the tutorial doesn't actually tell me where it is. Oh, it does tell me to require this thing. I missed that part. So let me copy this line. Ah, if I copied it correctly. Nope, I did not. There we go. I don't think that's going to get the right one, but let me delete that and see if the resolver can get it now. It's still wrong. So I don't know what the path is, but I think I can find it by looking at that repo we saw before. There's the path we need. There's the input path. So let's replace this silly AWS thing with that one. There we go. That's the right one. It's all part of the xtools thing, so it all resolves out already. Perfect. So let's look at that diff now. All right, 2 new imports as expected. One line change here, but the indentation changed on the others, so they've changed color. And then let's see about the actual logic here. Pass result of inspector.analyzer will be set if we've added inspect.analyzer to requires. Okay. And then we set a node filter. Filter needs nodes, visit only them. Okay. And then we say ast.funcDecl. We're passing it. So this syntax here essentially sets, it's a way to create a nil pointer to something of this type. So presumably, whatever uses node filter just looks at the types of the arguments. And so let me just pull up my editor here and I can show you. So that's the original. You could do this, I'm guessing. You could do that and it might look a little bit more natural, but it uses memory because it allocates a pointer to this type. And it allocates an actual instance of that that struct. But by doing it this way, even though it looks weird, it uses less memory. So it's a slight memory optimization is what that is. If someone reminds me, or I'll try to remember, but we can test that in a moment. But I think that's what that's doing. Then we call inspector.preorder node. So we pass our node filter, and then function node ast.node. So rather than using that inline inspect function, we're now passing that function to inspector.preorder, and this one doesn't it doesn't return a boolean, so that return true is always returned changed to just return. It returns nothing. So here's the old function signature. Func node ast.node return bool, and the new one is this, just func ast node with no return value. I hope that makes sense to everybody. I don't know why it doesn't take a boolean, but it doesn't apparently. Okay, so and then rather than ranging over these pass.files, we just call this inspector.preorder, which does the ranging for us. So it looks pretty straightforward. It's a little bit nicer, I guess. All right, let's run this one, see how things go. Behavior looks the same. Let's make a commit. What did we add here? We added something called. Oh, I went way too high. Inspector. Sure. Whoops. Can't spell very well. All right. Let's just push this up to GitLab 2. Now, let me go back and try to prove or test my hypothesis that this is just a memory optimization. So if I'm right, then this should behave identically. So let's compile that, run it again. Seems to be working. And probably also, even if it had, if it was a populated one, it would work. But rather than trying to test that, let's just see what node filter is expected to do, if there's any documentation about this. The types argument, if non-empty, enables type-based filtering of events. The function f is called only for nodes whose type matches the elements of type slice. Yep, so it's just looking at the type. The content of that is irrelevant. So my guess was apparently correct. Let me undo that then. Keep the slight memory optimization there. It's nice. What's next? We've changed the AST walking a little bit. Now we use inspector.preorder and don't return anything from the visiting function. The excerpt from the inspector's comments explains the profit from its usage. So I'm going to pull this up on, we just had that open, but I'm going to pull it up on here so it's easier to read. So I think it's quoting this. No, it's not. What is it quoting? From the excerpts from the inspector's comments. Oh, it's from the package documentation. All right, so it's quoting this part right here. During construction, the inspector does a complete traversal and builds a list of push pop events and their node type. Subsequent method calls that request a traversal scan. What? Subsequent method calls that request a traversal scan this list rather than walk the AST and perform type filtering using efficient bit sets. I love efficient bit sets, don't you? Experiments suggest that inspector's traversals are about 2.5 times faster than AST.inspect, but it may take around 5 traversals for this benefit to amortize the inspector's construction cost. If efficiency is the primary concern, do not use the inspector for one-off traversals. So in other words, this is probably actually making things slower for us, up to 5 times slower apparently, since this is a single invocation of a single analyzer. But if you're using something like Golang CI lint, where you're running 15 linters all at once, then you get the benefit. So I guess that's what that means. Let's continue. We expect our linter to be used from linters run like Golang CI lint. Such linters contain dozens of analysis analyzers. Therefore, we are sure that the inspector construction time will be amortized. And even if it's slower, it's just a simpler API to traverse syntax trees. I think that makes sense, yeah. Testing. All right, it's time to test our linter. I would love to do, I like to do TDD. So the fact that we're doing testing after sort of is backwards there, but that's okay because I'm just learning how this works right now, right? Once I finish this testing part, then I'll understand how it works, and then I can use TDD to build a real linter, which I'll probably do. If not today, maybe next week, since we're already halfway through the time here. In the file pkg analyzer test, which we're going to rename to just analyzer test, we write this. So let's do that. It's not the whole thing though. I mean, I know how to finish it, but it's not a full file. There we go. Well, it wants it to be a separate thing, so I'm going to do this. It expects it to be a separate package since it referenced the analyzer package directly. So I'll do that. I'm going to move this import to another group. I like to keep 3 import groups. If you're wondering why I did that, the first one is for the standard library. The last one is for imports in the same Go repository or same module, and then the middle one is for anything else. Occasionally, if I'm working for a large project, I'll have 4, or a large company, I'll have 4 groups, and basically between the other category and the local module, I'll have other imports from the same company. But that's usually only for large companies using lots of Go code. So that's just a quick explanation of why I broke that all up. Oh, the test failed. So sad. Oh, we don't have test data installed. Okay, we'll get there, I'm sure. Actually, before we do that, let's see what this test is trying to do. It's trying to get the current working directory, okay. And then it tries to read file from test data. Okay, that makes sense. And now I know why it was failing. If you're not familiar, the Go tooling treats test data as a special directory name, and it's intended for containing data that's only used in tests. So you can put even .go files in there, and they won't be compiled and linted and everything normally, which is great, especially for something like this, where we probably want to put, if you're building a linter, you want to put a whole bunch of Go files in there, and some of them might have broken code in them that if you didn't put them in test data, it would probably break your CI pipeline, because your CI pipeline would detect that there's broken Go code in your repository and tell you syntax errors or lint failures or whatever. So that's what test data is for, and that's why it's being used here. So now we need to put some files in there. Now it wants us to do test data /src/p/p.go. It seems kind of verbose, but I'll do it anyway for now. Maybe there's a reason. Now it wants it in. This is a little bit unusual. I don't like this, and I don't know if this comes from that repo I was criticizing before. They have a single test data directory at the top level of their package. I'm going to go ahead and do that right now, since I don't know where they're going with this, but I usually put my test data right next to my test. So in this case, it would go in the analyzer directory. So I'm not crazy about this, but until I understand fully what they're doing, I'm going to go ahead and follow the tutorial. But I probably won't follow that pattern when I'm doing a real linter later on. Right, test data slash sr slash p. And I'm going to create this file that contains this stuff. And it contains a whole bunch of functions. And my linter doesn't like it. My linter is running on this project with default settings, and it's complaining that I have code that's not being used. So I probably should disable that linter for this package. Yeah, I suppose I'll do that right now. I'll do it at the top here. That should make the linter happy. That little directive just tells the linter don't complain for the linter called unused. And this is the reason why, because they're for tests. All right, back to the tutorial. What's next? Now, all right, let's run the tests and see what happens. No such file or directory. But so I think it's because I'm not in the same directory structure they suggested. Yeah, they call filepath.dir twice because they have to traverse up the tree twice because they had the PKG path in there, which I don't have. So I'm going to remove that. I think that'll solve it. Yeah, now it passes. All right, let's continue down this tutorial. We're getting close to the end here. Did we finish with tests? No. Let's check our code coverage. Okay, let's do that. Let's add the dash cover. We covered 83.3% of statements. I guess we can do that with. Oh, I know what he's doing here. So what he's looking at, he's configuring VS Code to show which code is covered and which isn't, which I'm pretty sure happens by default. Yeah. So you can see here that this statement is not covered by my tests. It's got this red background. This one is not covered by tests, and this one, and this one. So we can add some more test coverage if we want to. And there's a screenshot. It's a little bit hard to see. Screenshot from VS Code. Oh my gosh, he doesn't use dark mode? What's wrong with this guy? You all use dark mode, right? Okay. Anyway. So yeah, some of these are not covered. So I'm not actually going to follow his tutorial here because I'm going to just do this myself. But we can see here that this is the first one that's not covered. What is it doing? It's the first param type isn't an identifier. Okay, I might actually have to look at his his example to figure out how to do that because that's what I was saying before. I don't know what else it could possibly be. So I'm going to go back on my word just immediately and figure out what the heck I can do to trip that one up. Some code blocks are collapsed. Yeah, okay. I've checked again. All cases except one are uncovered. The uncovered one is. I don't know. He has only one. Oh, he added this, I guess. All right. I'll go ahead and add. He adds 3 to cover the other 2. Okay. So I'll add those 3. It goes here. Second arg is on ellipse. Okay. Printf like, but with extra interface methods. Okay, so here it's an interface that takes, or that has methods instead of an empty interface. We talked about that earlier on. All right, and then what's this other one? Okay, so he agrees with me. He can't find a test case for this one. So this apparently cannot happen. Let's look at our covered code again. So now this is the only one that's not covered, and this is the one that actually cannot happen, apparently. So my early guess was apparently right. Still, it's not bad practice to check for that. Maybe some future version of Go will support a different type of argument or something, and you want to check for that. Or more likely, it's just you want to be clear that you're covering your bases. So somebody, if you leave that out, if you did this, somebody else reading your code might go, wait, you forgot to check errors or whatever. So, principle of least surprise, I think, makes it useful to still put that in there, even though if we expect it will never possibly trigger. All right, did we finish with tests? No, we've forgotten about important tests. About this person forgot some articles in his English. He's probably not a native speaker. No, we've forgotten about an important test case. All right, what's the important test case? I'm not sure, but let's copy this and see if it makes sense. So the important test cases we have functions that look like printf, but they take an extra argument. So in this case, it's called extra arg. Extra arg. What's the difference here? Oh, this one is a string, and this one is an integer. So apparently he wants to cover these, which probably makes sense. But our current code does not. Yeah, so we run a test here, and we get failures. So let's fix our code. So now we're doing some TDD. We write a failing test first, then we make the code work. I like that. So here we are over Analyzer. And what does he say? I'm not sure exactly what. I can guess where he wants us to go, but params. So now so he changes it to if len params is less than 2 rather than exactly equal to 2. So let's do that. And then next, if okay, so then basically he's requiring that only the last 2 arguments are string and variadic any. Anything before the last 2 arguments can apparently be anything. So here, rather than checking params 0, he checks params len params minus 2. Makes sense. This stays the same because we're still calling it format param, although he renamed this from first to format, which makes sense. Since it's no longer necessarily the first, it could be anywhere in the string list. All right. And then he changes this one to args. So let me do args param type. And then args param is, rather than 1, it is len param, len params minus 1. I think we're done there. Let's see if the tests work now. Yay, the tests pass. TDD for the win. Let's commit our changes. Should have committed go.sum a long time ago. Anyway, I'll do it now. All right. Run it on Go source code. Haha, let's do it. So go install.cmd. All right, linter tutorial is now installed in my path. And then we're going to cd to go root src. This isn't useful because I don't have go root configured, but it should be user local go. There, that's what it really wants. All right, we're going to run the linter tutorial on the entire Go standard library. I bet it'll fail somewhere. The log package at least has some functions that I think will fail, but we'll see. I don't know how long this is going to take. If it takes too long, we'll abort it and just claim success regardless, but hopefully it doesn't take too long. While we're waiting here, anybody have any questions or comments to share? There we go. One failure. Format function warning should be warning F. It's an internal function, so it's not actually even in something that it's not an exposed function in the center library. Curious what it is. Let's look at it just for the heck of it. Internal coverage pods. I don't know what that is. Pod encapsulates a set of files emitted during executions of a coverage instrumented binary. So this has to do with actually code coverage statistics, apparently. It's very definitely an printf style function. It takes a formatting string and a list of arguments and prints them to standard error. Yeah, okay. So it wasn't even a false positive. That's cool. Still don't think it's very valuable, but it worked. All right. So when he ran it, he got back 30 issues. Apparently they fixed some of them. Some of them are valid. Some of them are false positives. That's interesting. Why did I not get the same failures? Because some of these are exported functions that I would expect. Okay, I'm really curious now. So you see this one in query. That must be in database SQL. Huh. TX. We'll do it this way. Database SQL. Maybe it's not here. I think that's it. This is probably interface type, right? No? Anyway, so the point is this is a false positive. I don't know why it's not showing up in my test, but it's a false positive because this is not a formatting string. It's a query string, right? With the arguments fill the placeholder values. That would be like select star from foo where user ID equals $1 or something like that if we're using MySQL. That's what this is supposed to be for, I think. I'm not sure why I'm not finding it. I'm more curious though why I didn't have the same failure. So I'm gonna, I wanna cause these failures to happen for me too. Did I not do it like that before? No, I still have only one failure. It was a lot faster this time. It's caching things. That's cool. But why am I having only one failure? Anyway, let's continue reading the tutorial here. The proper fix is to trace all calls inside such functions and find out whether format argument go to formatting functions like fmt.sprintf. Maybe we will do this in the next post. For now, let's make a simple fix and require that format argument name is equal to format and don't allow return values. It will increase precision of our analysis but will decrease recall. Statistical stuff. So I don't 100% agree with the idea that that's the correct solution, because I mean, that would not have caught the one that we actually caught, right? This one. I don't think it would have. Let's check. It would have actually caught this one because we're calling fmt.fprintf. But it wouldn't have had to. Like there's no reason that we would have to be calling fmt.fprintf here. You could implement that yourself, right? Or maybe you're calling a log.fprintf or infof or something like that. So I'm not sure that is the correct solution for this. Not that it really matters since I don't really want this linter to work. But it's a way. I mean, certainly it would be a positive way to verify that it is a formatting string, but it could have false negatives, I guess is the point. So I still am very curious why I'm not catching these false positives. He got 30 failures, I got 1. I don't know. I don't even know where to start debugging that, or I would do it. All right, let's see if we want to finish up here. This is the part I might want to skip. Integrate with GoVet. Oh, it's really easy. It's a command. It's not even integrating from a source code level. It's integrating the command line tool level. So you do GoVet and then vet tool, and you tell it which tool. And so that would be the path to my binary. So yeah, I'm going to skip that. I don't want to bother with that. Oh, here we go. How to integrate with Golang CI lint. This is much more interesting to me. Golang CI lint is a linters runner. He's the author of it. It contains dozens of linters. Let's add our own. The main part of adding it is I don't know if this is in our project or in Golang CI lint project. In the end, don't forget to do make bin. So this has to be on the Golang CI lint project. Let's pull that up. I'm not going to create a pull request, but I want to see how it's done. What do I get? There it is. So he's saying to close that. PKG go linter. PKG go linters. And then go print. So we add our own linter here. So his example is go print f func name. And that exists here. I'm pretty sure he added this just as an example, although you can use it. It is an actual linter. So here's the file, and then he has the new go print f func name there. I guess that's kind of it, huh? And then make a pull request. So, he put all the source code, the whole thing in there. Not, but I suppose it could be a link to a an external library that you create. So, if I were to create a linter that I wanted to add here, I'd probably create my own library, and then have the pull request just reference it. So here we can see his pull request to add that. I guess he kind of did the same thing, maybe. I don't know why he didn't mention that in the tutorial. He left that out, and maybe there was a reason. But here there's some I don't know what that is. So here's the thing he mentioned. It looks like we're adding configuration hooks of some sort. And that seems to have been left out in the tutorial. But it's also really simple. And then they're using vendors directory, which is why he mentions that here, make vendor readme. Okay. If I ever commit, or if I ever submit a pull request to Golang Salient, I'll be sure to do that. But that's what that's for. That's kind of cool. So I think we're basically done. We've built a linter. Maybe next week I will try to build a useful linter. I don't know. Or if anybody here has an idea for a linter they would like to see built, maybe we could try that. We could, if there's something that bugs you about your source code, or more likely the source code of other people, we could build a linter. I have a couple ideas for things I might try to do. Some are fairly simple, so that might be a good project for next week. But I think we made it through tutorial, so that's really cool. I see there's a question in the chat. I'm not exactly sure if I understand it. Do you have time to show the cast nil to type example? I'm not sure what that is. Can you refresh my memory? I'm sure it's referencing something I said. Can you refresh my memory what I was talking about? And I'd be happy to try to do that because we have plenty of time. One other comment I have is that I'm not super excited about the way these tests are done. So that we test the whole thing, and we expect to have no output. That's not how I want to test the other way too. I want to give it some bad code and be certain that I'm getting an error in return. So that's something I'll do maybe next week or maybe I could spend some time on that today. But I definitely want to see proof positive that it's finding errors, because this test would pass if I just deleted all the logic, because it would just find no errors and that would be passing. So yeah, let's do that. Let's work on that. Oh, I see the comment now. You were talking about the ast.file nil. I did talk about that a little bit, but let me do it again. I think we were talking about this part. So basically, this would be functionally the same. The difference is that it allocates more memory. And maybe you dropped off during that part of the session. That's fine. I'll go over it again quickly. If you want more detail, maybe you can jump back and watch the replay later. But my guess was that all we cared about was the type of the data, not its contents. And so I tested this, and it worked, which added credence to that guess. But then I looked at the Go doc over here, and it confirmed my suspicion. The func f is called only for nodes whose type matches the element of the type's slice. So it's only looking at the type, not the actual content of the variables in that slice, which is why this is done. So this is just a shorthand, or not a shorthand, but this is an expression that lets you pass a variable of this type that has no data. It's a nil version of that. So I hope that clarifies. All right, so what I want to do now is I want to write a test that fails, or that the linter fails, right? So I made comments earlier about test data and how I don't like this project's way of putting test data at the top level. So I'm not going to do that for this test that I'm writing. I'm going to do the test data where I want it to go. So I'm going to go into my analyzer. I'm in the wrong directory here. So I'm going to go into analyzer and make my own test data directory here. I like my test data directory to live directly next to my _test.go file. So that's what I'm doing. Now, in here, I'm going to create, I'm going to actually copy the example file I started with that had the failure, right? So that's just 2 levels up here, example, and put that here. All right. Now, and see, by putting by putting my test data directory next to my test, I don't need to mess with any of this nonsense about get WD, because it's guaranteed that my working directory is where the test file exists. So that it would make the whole test so much simpler. And I'll just show you. I'm doing that here, so you'll see exactly what I mean. So I just copy this. And then instead of test data, I do test data /main.go. Now this is going to fail. It should fail. Oh, I'm in the wrong directory. It's not a directory. What are you talking about? Do I need to do this? Oh, it's trying to load P because P doesn't exist. It should be loading main, I think. All right, I'm confused what that references. So let's look at whoops, let's look at the doc here. Okay, so that's a dir, not a okay. So this should just be test data. See if that's right. Maybe this is going to make a liar out of me and make all my bickering about test data directory position irrelevant. Maybe these tools require this sort of nitpicky stuff. Go path entry is relative, must be absolute. loads the packages from the specified GoPath style project directory, runs the analysis on them, and checks them. An expectation of diagnostic is. So it's interesting, it looks like I can pass in a list of expectations. I guess that's what patterns is for, but I'm still not understanding. Right, let me get rid of this for now. I just want the analyzer to run successfully is all I want at the moment. Instead of fail with this. Let me try it this way. I think this is, I think it looks ridiculous, but maybe it's actually necessary for this tool to understand how to do things. So that made the test work in the sense that it executed the analysis correctly. The test failed because I haven't made any sort of assertion that it fails with this error. I wonder if there are, I'm going to look at the go doc for this further. I want to see if there's a better way to do this. Maybe there's not, but I want to see. Okay, it returns a result, which we're currently ignoring. There's also this run with suggested fixes, which behaves like run, but additionally verifies suggested fixes. It uses golden files placed alongside the source code under analysis, suggesting fixes for code and examples.go will become. Well, it looks like this extra nonsense is required for this tool to work, which is unfortunate in my opinion, but it's not the worst thing in the world. It still works. It's just annoying. Maybe I can, with enough time, figure out how to fix that, but I think that's all right now. So what I haven't done now is verified that I get the failure I want, although it looks like this is supposed to handle some of that for me. What I'm concerned about is, let me read this a little bit more. A single want comment may contain a mixture of diagnostic and fact expectations, including multiple facts about the same object. Okay, I need to understand this better. An expectation of diagnostic is specified by a string literal containing a regular expression that must match the diagnostic message, for example. So I guess I can add, maybe that's already being done and I just overlooked it. Let me look here. Okay, it is being done. Okay, my concern was unfounded. This tool is just too smart for me. So you see this want, this is actually verifying that that happens. Okay, so let me delete what I now realize is an unnecessary test. And let's just verify that this does what I expect. Go test dot slash dot dot dot. Everything passes. Okay. So let me change this want to something else. Let me just put some nonsense in here. Now it should fail if it does what I think. And indeed, it does fail. So that's already much smarter than I expected. So it is positively checking that these return failures. So that's great. That's actually a pretty powerful testing tool. I'm happy with that. I think this is maybe one place to mention though. The Go community as a whole has more or less decided. I shouldn't say as a whole. The official Go project, sort of the official advice for Go, is to not use assertion libraries. Let me just show you where that's documented. So GitHub, it's on their wiki. github.com, going, go. If you go to their wiki, let me zoom in a little bit. Wiki, and this is some great reading, by the way. Code review comments. Some great suggestions here about good code formatting and styling and conventions that practically every Go team should use. So if you're on a Go team and you're not doing these things, it's a good idea. And then related, I have one about testing, I think. So here, Go test comments. And here's what I was getting at. Avoid the use of assert libraries to help your tests. Go developers arriving from XUnit frameworks often tend to write code like this. But this either stops the test early if assert calls t.fatal or panic, or omits interesting information about what the test got right. It also forces the assert package to create a whole new sub-language instead of reusing the existing programming language Go itself. Go has good support for printing structs, so a better way to do this code is blah. Another complaint I have about assert libraries and things like that is it has a tendency to sort of hide magic. And the reason I'm bringing this up right now is I feel like what I just experienced was hiding magic. So although it's a nice, powerful tool, and it didn't take me too long to figure it out, it's not at all obvious from this that it's doing the testing I would expect. I don't know. I don't have a concrete proposal, and of course that ship has sailed. That library already exists and it's heavily used, so they're not going to change it because I'm complaining. But I just want to point this out. If you're writing tests on your project, make them as clear as possible. I mean, we want our code to be clear. It would be good for your tests to be clear too. And you just saw me struggle through trying to write my own test, all just to discover that it was unnecessary. So that's one reason why assertion libraries and extra helper libraries for tests are discouraged in Go. It's ironic and a little bit unfortunate that this project from Go didn't really follow that advice, but that's another question. All right, I think I had scheduled for 2 hours, but I think this is a good stopping point. We've built a linter, we've tested it, we've talked about some different bits. I think I'll be doing this again next week at the same time, so I hope you come back. I don't know yet what I'll be doing. If you have suggestions, let me know. We could build a proper linter that does meaningful linting instead of just a toy. We could do something else. Let me know your thoughts in the comments here, or head over to boldlygo.tech. You can find my contact details. Send me a message on LinkedIn or my email or wherever. I'd love to hear what you'd like to cover, and I hope to see you all here again next week. Thank you so much. Talk to you later.